So let's take a look at the next part of today's lesson. So the next page, we're talking about how does systems of equations relate to the business world. This is probably one place where graphing does come into play in the real world. Now we saw from our first example, we compared two types of jobs and which one was better at a certain time. Now other places where it would come into handy would be places such as, and I'll just make a list here, profit. Okay, profit. Okay, if I was looking at systems of equations for profit, I'm looking at the intersection between cost of something or creating something and the income that it brings in. And so the point of intersection in something like this would be it costs me $20 to make this, and I would need to make, if I'm making a profit of $0, I would have to bring in $20 as well. Okay, so that's one place that in the business world it would be interesting to know. Okay, another place where it comes in is best deal. So best deal is actually like what we just did with our first example, and it's comparing things. So if I'm comparing jobs, if I'm comparing cost. Another thing would be if I'm comparing product comparisons. How much does this product cost to create compared to this another product? Insurance is another one. Upgrades to buildings. If I do this to the building, it will go up by this amount. If I don't do that, this is what's going to happen, and that includes repairs as well. Okay, so those are some of the things in the business world where systems of equation are useful. So now what we're going to change to is what are some of the possible solutions you can have for a system of equations. Now you can see that I've divided my page into three because there's three different possible solutions. Okay, one possible solution is I have one solution. And the way this would work is if I have, and I'm just going to move this out of the way. Oops, sorry, that moved everything out of the way, which I didn't want. I'll just move it over here then. I want a line, and it doesn't need to be really big. And we'll change the color. So one solution, it would mean that I have one line, and then the second line that I'm going to create, they intersect somewhere. And so my solution would be this one point. Okay, so one point, that's where they would intersect. The next possible is no solution whatsoever. And this would happen if I had a line that went like this and my other line was like this. Okay? Now, these would be what we would call parallel lines. And you know that parallel lines do not intersect. Okay, they're going up at the same rate or going down at the same rate each time. So parallel lines, if they have the same slope, okay, the rise and run is the same for both of these lines, they will never intersect each other. And if they don't intersect, there's no solution. The final kind is a little bit harder to kind of understand because, well, it's not harder to understand, it's just different in the sense that I have one line and then I have another line like this. And you're saying, what happened to the first line? Well, it's still there. It's just that in this case, there's what we call infinite solutions, which means there's millions of solutions, infinite number. We can't find, because they're intersecting at every single spot. Okay, and what you have when you have this situation, they're not parallel, it's what we call the exact same line. So what do you mean exact same line? Well, I can write a line in more than one way. So for instance, if I look at this line here, I have y equals 4x minus 6. Well, that is exactly the same as 18 plus 3y equals 12. The difference being, they look very, very different, is one is rearranged differently than the other. So they are the exact same line if you graph them. Okay, so 3 different possible solutions. One where there's one solution, no solutions, and infinite solutions. So what we're going to do now is we're going to do we're going to do one more example. And the example that we're going to look at has us graphing 2 lines and seeing whether they intersect once, whether they're parallel, or whether they're the exact same line. So here we have the 2 equations I want to look at. So it says, first of all, determine the solution to the system of equations. So remember, the solution is a point of intersection. Now, both of these are going to be a little bit difficult to graph because neither of them are in the form y equals mx plus b. Okay? So when I look at this, x plus b. Now, oops, I just didn't want to write anymore. So what I can do with this one would be the easiest one to switch into this form. I'm going to subtract 2x from both sides. And by doing that, I end up with y equals, the 2x's are gone, negative 2x minus 5. So when I go to graph this one, and I'll graph it in green, I know that it starts at negative 5, so 1, 2, 3, 4, 5. So there's that point. And then it goes down to over 1 because it's negative 1, 2 over 1. Now it's really hard to see that, right? I'm going to go up 2, but then go the opposite direction. So this is where my equation is. Now all I really need is 2 points in order to graph this, and so that's what I'm going to do, and I'm going to choose green. And you can see that I haven't done a very good job, so I'm going to have to rotate it a little bit to get it to go through those points. So not too bad. So that's the first one. The next one is a little bit harder to do. Like for me to rearrange would take too much work in my opinion. So what I'm going to do is I'm going to make a little quick table of values, and obviously I'm going to choose really nice numbers to do that. So I'm going to do an x and a y. For my x, I'm going to choose the number 0 because it's a nice number. So that means I have 2 times 0 minus 3y plus 9 equals 0. That's the same as negative 3y plus 9 equals 0. I'm going to subtract 9 from both sides, so you can see it's a lot more work. So that's negative 3y equals negative 9. And then what I'm going to do is I'm going to divide both sides by negative 3. When we do that, we end up with y equals negative 9 divided by negative 3 is a positive 3. So when x is 0, y is 3. So that's up here. Okay, so that's the first point for that one. Now I'm going to do the same thing. I'm going to choose another number. Do you know what might be easier would be if I choose 0 for y, and there's nothing wrong with that. So if I do that, and I'm going to just move this up a bit. So that would be 2x. This here, this part of the equation would equal 0. So then I have plus 9 equals 0. Subtract 9 from both sides, and then divide both sides by 2. And so I have x is x is negative 4.5. So when y is 0, x is negative 4.5. So 1, 2, 3, 4.5 is here. Okay, so now I'm going to join those 2 points together. And so I'm going to bring up my line maker. Give me your line maker. Do as you're told. Okay, and again, it doesn't go right through the points I have. So something like that. Okay, so my answer then to this question is where they intersect. Now you can see that they do intersect, and it appears that they intersect right here. Now you maybe have already discovered that there's a little issue when you're graphing, and some of it has to do with how accurate you are with your graphs. So if I want to then write the answer, the solution will be the point. And remember, a point has an x and y value. So if we look at the x and y value here, so I'm looking at 1, 2, 3, so negative 3 and positive 1 for the y. So that is my solution. So therefore, negative 3, 1. Okay, so what you're going to be doing today is you're going to be graphing lines. Some of them are easy to graph, some of them take a little bit more work. We'll do this other question together tomorrow when I'm back. So in your textbook, there's questions 2 and 3. I also have for the supply teacher to give you some grid for the graphs to make your life just a little bit easier. Okay, so good luck and I'll see you tomorrow.